Number three is to do with Riemann sums. And the question says the amount of water in a tank is modeled by the function W of t in liters. So W is in liters, t is time. And it says determine the average amount of water in this tank from t equals 0 to t equals 15 using left-hand Riemann sums. So a couple things here. We should really sketch out this diagram so that we have an idea where the points that we're going to use to calculate the areas are. So I've drawn a graph here, and the green dots represent the y values or the height of water, the amount of water in the tank. Okay, and I've drawn left-hand Riemann sums here. So the left edge is going to be the point that we're given. So for example, at t equals 0, w is 10. So I've used that point because that's the left edge of that interval. The other thing is we are dealing with an average amount of water. Okay, so we're going to calculate the area, so the total area, but we're also going to work out the average value or the average height, which means that we need to use a formula for that. Okay, so you're calculating each individual rectangle here. I have a 2 by 10 rectangle. I've got a rectangle that's 12 high, 3 wide. So that's 36. The next rectangle is 16 by 1, so that's going to be 16. The next rectangle is going to have from 6 to 8, so it's going to have a width of 2. It's going to use the left edge of 11, so 22. Next interval has an interval of 2 again. The left edge, though, this case is 15, so it's going to be 2 times 15. And the last interval has a height of 20, but has a width of 5, so that's going to be 100. Okay, that's going to be 100 liters. So the total area under this, when I add this up, is 10 plus 36 plus 16 plus 22 plus 30 plus 100. That works out to be 46, 62, 84, 114, so 214 liters. That's not liters, but liters times time. Okay, we don't know what those units are, but the average value of W, that's going to be equal to 1 divided by the interval width. So it's going to be 15 minus 0. It has an interval width of 15. And then the area of 214. Okay, and then this works out to be 214 over 15 liters. Okay, so that works out to be, looks like to be about maybe 14 liters, somewhere around there. For example 4, we're going to practice doing antiderivatives, and we're going to use antiderivative, and we're going to calculate the definite integral, so the area under the curve. So here we have 2 over x plus 4. This is not power rule. This is our exception because when we have x to the power 1 in the denominator, that's a negative 1 power. If we add 1, we're going to end up with 0 power, and then we're going to divide by that 0 using the power rule. That doesn't work. Okay, we can't divide by 0. Whenever we have a linear function in the denominator, this is a log function. So I'm going to take the 2 out. We're going to end up with log x plus 4. And then we're going to integrate this from x is 0 to x is 5. So plugging in, we end up with log 5 plus 4 is 9. minus log 0 plus 4 is 4. And then since this is subtraction of logs, we have a way, when we subtract logs, we have a formula for that. We're going to divide the arguments. And so that's going to be the area. Now, when we work out this area, it works out as a decimal to be about 1.62 units squared. Okay, for the next function, when we anti-differentiate, so if we're going to find the definite interval, we need the antiderivative here. The antiderivative of 2 to the power x is itself 2 to the power x, but because we are not using a base e, we need to make sure we divide by log of that base, so log 2, plus the antiderivative of cosine is sine, and we're going to integrate that from 0 to pi. Now we can plug in our values, so we're going to end up with 2 to the pi over log 2 plus sine of pi, which is going to be 0. So that's going to be the first part of that. And then we have to subtract the other bound. We end up with 2 to the power 0 over log 2 plus sine of 0, which is 0. Okay, so simplifying this, we end up with 2 to this becomes 0. This is 0, so we end up with 2 pi minus 2 to the power 0 is 1. And that's all over our common denominator of log 2. That's our area. This works out to be approximately, when we work that out, approximately 11.29. And that's area, so we'll call that units squared.